Continue. All right, so today we have Alan Ling from CoMSES, and Alan is going to be introducing a briefing. Alan is going to be giving us a brief talk about how to build machine learning data creation workflows. Alan is a computer science and research software engineer, working on improving our abilities to understand and how to make models more transparent. So, Alan, with that, please go ahead.
Thank you, Daniel. So I'm going to talk a little bit about how we got to working on these sort of data curation workflows that use machine learning. Machine learning, of course, is a hot topic these days. A lot of our undergraduate developers are interested in that, but that wasn't what we initially started them on. So the first problem that we had is that good RSEs are hard to find. Competing with the private sector to hire qualified full-time RSEs has been a challenge for us. We've had a NSF grant where we've been trying to hire 2 full-time RSEs for the past 2 years now, and still have been with attrition. We're still too short. So we pivoted towards trying to build this kind of student pipeline, the student developer pipeline, kind of like the Sudo program from the University of Utah. In January of 2023, we hired 4 student developers, and we asked them to build a metrics page for our Science Gateway. That looks like this. It's in production now. As a result of working on this this metrics page, we ran into the issue of clean data, and it's something we had been aware of, but we sort of figured out that this would be something that would be of interest for the students as well, for their career, the things that they're interested in. We had 1 data scientist in our team. So we started to explore at first just focusing on deduplication and entity resolution. So we have our Science Gateway allows user contributed metadata, like most, right? So we are all scientific software registries and repositories. That means scientists and researchers are submitting metadata to us, and we care deeply about how the quality of that metadata. So people will make typos. They enter things in incorrect ways. So this sort of folksonomy that emerges needs to be curated over time. So our first focus was to improve the metadata and create sort of human in the loop tools that would allow a curator to sort of cluster metadata and then handle this sort of process of entity resolution, as it's called. Another issue that we often run into is spam content, and for us, this most recent set of users, I think 95% of them are all spam. They enter spam events. They've started to enter spam code base entries as well. Those embarrassingly get also propagated to our Twitter and Mastodon accounts in an automated way, which improves their reach and also puts egg on our face in terms of what the kinds of content that we're promoting. So these are things that we want to minimize and address as well. So with that in mind, we started to explore this rapidly evolving machine learning ecosystem. The last time I did any sort of work with artificial intelligence or machine learning was during grad school in 2002, and that was a very different landscape, building neural networks and fuzzy logic thing like toy models in Scheme at Indiana University. And so now the field has literally exploded, and I have no idea what I'm doing. So so we tasked our developers with kind of to explore this space. Is everyone here familiar with Hugging Face? And also please feel free to chime in if you have any questions or if I'm moving too quickly. So Hugging Face is a repository of AI and ML models. It is bewildering to start with, but maybe we can we can explore it together later if there's interest. Another resource that I found quite useful was the Fast.ai course. That helps sort of bring in an interactive way the concepts of machine learning into sharp focus. There's this huge proliferation of libraries, as you can see here. I think the most what we standardized on was tended to be towards PyTorch. Other things that we had to really develop a lot of competencies in was just data manipulation in pandas. So a lot of the work that we were doing revolved around Python ML libraries and pandas, PyTorch, and scikit-learn. So in for this original task that we had of data cleaning and entity resolution, funnily enough, entity resolution is also called all of these things. So it's a little bit like the shoemaker. It's very meta for them to have so many different terms resolving to the same thing. But the short of it is we want to have a set of tags, and we want to establish with a curator's help what a canonical tag is. And then in our user interfaces, we want to present those canonical tags over the set of all possible tags. So this is something. So what we've been working on is building these backend tools. Our Science Gateway is implemented in Django. So for those of you who are familiar with Django, we're building management commands on the console that allow a curator to essentially label training data and cluster tags together, saying that these tags that we looked at uh, these tags that we saw here, they all map to this single canonical tags, and we sort of like build these data structures in the back end. Eventually, we'll work on building a web-based user interfaces for curators to operate this to do this process. But for now, we're sticking with more console-based interfaces or command line interfaces. So for in order to do this entity resolution, we leveraged an open source library called dedupe. It took a little time to work with, but it's quite excellent. It offers this sort of like manual clustering and labeling. You generate it generates sort of these large JSON files of training data, and over time we can refine that data with curator assistance. So another thing that we built that we had our students work on was these Jupyter notebooks that kind of describe the process that they underwent on sort of like building these tags and the rationale for doing so. I'll provide those links. Well, you can get to the links from these slides, and I'll share the slides after this presentation. This was for our 2023 NSF CSSI PI meeting. We included this on our poster. So this gives a quick sort of overview of the kinds of things that we wanted to implement using machine learning. So for entity resolution, we basically just used dedupe. Dedupe uses machine learning libraries behind the scenes, so we were not building a model explicitly there. We're kind of punting that to the dedupe library. For spam detection, this was this is still a work in progress, and it's been a bit more involved. So we've been working. So there's multiple things that we want to evaluate for spam. There's the content, obviously, as we saw earlier. We have events and jobs that can be submitted to our Science Gateway, as well as these code bases, and we want to be able to evaluate that content for spamminess. So in order to do so, we kind of have to take all of that metadata and massage it into data frames, into pandas data frames, and then use those data frames to sort of make these predictions. Um, there's a lot of work that's needed to sort of carefully prep and design, architect, and document these data transformation workflows, and kind of make sure that we can flexibly add new fields if we add new fields to our schema, for instance, or if we decide that one corpus of data, like the bio for users, including the bio or research interests that users, oftentimes spam users will create. Uh, they'll add their content in their bio, for instance, that has links to the casinos and other malware laden sites that they want to share. So um, making that flexible and maintainable has been that's been the ongoing challenge for us, as I think there's this famous paper from 2014, I believe, that characterizes machine learning as the high interest credit card of technical debt. So in this, for spam detection, we've been basically evaluating multiple models, where we've tried using pre-trained models from Hugging Face, and so maybe we can go to Hugging Face really quickly. Let me show you what that looks like. So Hugging Face is this model repository, and of what I guess would be called pre-trained models. These are models where all the hyperparameters have been already established. These models have been trained on a very large set of data, which is extremely expensive. So for instance, this one has been trained on, fine-tuned on SMS spam, which would be text messaging spam, and you can kind of play around with it and see that this, given this text, it would classify it as spam or not spam. So with the helpful label of label 1 or label 0. Label 1 is spam, and there's a confidence interval of 0.902. So Hugging Face there's these great libraries, Python libraries you can just install and access these models. They cache them locally. They download the models and cache them locally on your system, and you can just use them immediately to sort of classify your data once you get your data in the shape that they can operate on, of course. So the other the other issue that we're sort of having to deal with is kind of assessing how well these models are working. As I had indicated, we're exploring sort of hand rolling or training our own model, and this was a model that one of our developers built using the XGBoost library. This is a gradient boosting machine learning library for sort of classifying text. We manually labeled all of our user data as spam or not spam, and then kind of you have to sort of create this test split between training data, testing data, and then validation. So we built these this hand trained model, and then we've been comparing it with this SMS model that that's coming from Hugging Face, and it turned out that it might be because of overfitting, but currently this XGBoost gradient boosting model works a lot better than the SMS BERT model that we pulled from Hugging Face. But this is something that we're still continuing to assess and evaluate. We might need to fine tune the SMS model a little bit more to get better performance. Other things that might be useful to go over is this sort of idea of a confusion matrix. So how many are people here familiar with the notion of a confusion matrix? Yay,
I
nay?
am.
I am.
Okay, so I don't need to go into this too much. The main idea is to assess whether or not, in our case, we care about the F1 score, This is just a model metric that evaluates how well sort of it's a metric that sort of balances precision and recall. So these metrics that are often used for these machine learning models, precision can be characterized as the sort of like what proportion of positive identifications was actually correct. So this is good for cases where you care more about true positives and you might want to minimize false positives. This accuracy is this like a very broad, what were the total number of correct predictions over the all predictions. And this is one that you can almost always skip because it doesn't work well with these like class imbalanced sets. For example, if you had like 100 tumors, is this classic example. You have 100 tumors, 91 of them are benign and 9 are malignant. Our model identifies one single malignant tumor. Well, it has an accuracy of 91%, but really it didn't discover 8 malignant tumors. That's awful, right? Recall is this notion of predicted, what proportion of actual positive.
I don't hear you.
Yeah, we lost your voice, Alan. Are you there with us? It looks like we have lost Alan. And close to the end of the call as well. So I'm gonna let him know in the chat.
I still see him.
I see him connected, but
Nope.
but
Now I don't.
Nope. Okay, he dropped off. All right. So I'm gonna stop the recording right now then.